Hello, I'm Bill Inman. It's a real pleasure to be speaking with you this morning about one of my favorite topics, data architecture and the data lakehouse. Welcome to the Data Lakehouse Symposium put on by Databricks and myself. We hope you find the information to be useful and interesting. Before we start, I need to tell you a couple of things. First off, uh, 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 I, I, I recently had a case of COVID and I was left with a cough. I hope that the cough does not interfere with our presentation today, but if it does, my sincere apologies. You may rest assured that there's nothing that I can do about it. So I beg your forgiveness before we start. I will do my best to not have the cough. The second thing I want to say is the symposium that we're going to be having is not a sales pitch. This is an educational event, and it's meant to be that way. And please take it in that way. Some other housekeeping items. We will have the opportunity for questions and answers at the end of each day. And this is your chance to ask questions through chat. Now, what we're going to do is we're going to take the chat questions that are asked, and after the seminar, after the webinar or symposium is over with, we are going to then answer them and send them back to all of the participants. But we will have the opportunity for live question and answer at the event at the end of the event. Now, this symposium is designed for 4 days, and that's a lot of information. And so we know that people don't have that much time in terms of their work days and what they're doing. So we are going to be recording this, and if you would like the recording on demand, we will be happy to supply it to you. Along that line, you can listen one day and not listen the next day. So that's strictly up to you as to what you want to do. So I thought you needed to know that before we get started. There is a book that is related to the material that you're going to be seeing. You can get it by going to the Databricks website and download it from there. So I just want to mention it. And two of the authors, myself and a gentleman named Ranjit Srivastava, are going to be presenting. So you'll have a chance to actually hear from the authors of the book. Before we start, I want to tell you a little bit about the agenda. The agenda is today, I'm going to do the opening presentation, and then after I've spoken, a gentleman named Robert Scott is going to be talking about something called data lineage, which is an important part of the data lakehouse. Tomorrow, Dave Rapine is going to be talking about managing text in the data lakehouse, and Valerie Bartelt is going to be talking about visualization. On February the 3rd, Ranjit Srivastava is going to be talking about housekeeping, and Patty Haynes is going to be talking about compliance and governance. And then on day 4, February the 4th, on Friday, our friends from Databricks, Jason Pohl, is going to be talking about the infrastructure of the data lakehouse. And then a gentleman named Sean Owens is going to be talking about the machine learning that is an important part of the data lakehouse. So that's the agenda. I believe that the agenda has been published, so you can use that to determine what you want to dial in for. And in any case, it's great to have you here today, and I appreciate your interest. So I want to begin the presentation today with something with a little bit of perspective. I want to introduce our presentation that you're going to be seeing. First off, I want to talk a little bit about data architecture and the data lakehouse. When the way I understand things is that data architecture is an ever evolving thing, ever evolving architecture. It's like the Mississippi River. If you've ever lived on or near the Mississippi River, it changes all the time. No 2 days are alike, and there's constant change, constant evolution of the river. And data architecture is the same way. So when we take a look at the evolution of data architecture, what we find is that everything started with applications many years ago. And then from applications, we went to online, high performance, real time applications. And then from online high performance, real time applications, we went to something called data warehouse. And then from data warehouse, we had data marts. And then from data marts, we had things like the personal computer start to make their entrance into our world. And then after we had data warehousing, we found that we could start to put text meaningfully and usefully in a data warehouse. And so the latest addition to this actually long evolution is the fact that we now have data lakehouse. I look at data lakehouse as merely the next step in the evolution of data architecture. Now, it's kind of interesting, this evolution of data architecture. One thing that's interesting about it is the fact with the speed with which it has occurred. If you've ever stopped to think about evolutions in this world normally take a long, long time. I mean, when I say a long time, I mean thousands of years and maybe even tens of thousands of years is how things typically evolve. But the evolution of data architecture has really been from about 1960 until today. And that in itself is kind of interesting because in terms of evolutions, that's lightning fast for evolutions. And so we find then that we in our lifetime, our professional lifetime, have been witness to an evolution that is taking place. By the way, is data lakehouse the final step in the evolution? I don't think so. I don't know that for a fact, but if we were to look forward 10 years from now, we're going to find out that data lakehouse is merely the next step in the evolution. I don't know what's going to be after data lakehouse, but I feel pretty confident there's going to be something simply because that's the way that evolutions go. So the first perspective I want to share with you before we start is the fact that when we are talking about data lakehouse, if we view it in terms of an evolution, that it helps us to make sense of what is happening and what has happened. The second perspective that I would like to share with you is one on the components of data lakehouse itself. I liken the data lakehouse to a symphony orchestra. I don't know if you've ever seen a symphony orchestra, but there are many, many different parts to a symphony orchestra. We have the violins, we have a cello, we have the flute, we have drums, we have the piano. And in order to make beautiful music, we need to put all of these instruments together. So in this symposium that we're having today and the next 3 days on the calendar, we're going to be looking at lots of different aspects. And each of those aspects is similar to going in and learning how to play the flute, or going in and learning how to play the violin. That people spend their life learning these things. And so when we take a look at the totality of what is the data lakehouse, we need to understand that there's lots of moving parts. And if we're going to make beautiful music together, we need to put those parts together in a rational fashion. Just throwing the parts together and hoping something comes out is not a very good solution. We certainly don't have symphony orchestras that do that. So that then is another perspective I want to share with you, because today Robert Scott is going to be talking about data lineage. Tomorrow, my friend Dave Rapine is going to be talking about what do we do with text in the lakehouse. And then we have the issues of housekeeping. Then we have the issues of data governance. And so, and visualization. And then we have the infrastructure itself. So these are some of the different parts of the data lakehouse. Now, by the way, along that line, when I decided to put this event together, we tried to cover what I felt were the most importance of the lakehouse. There are lots of other aspects of the lakehouse that aren't going to be covered simply because of the time. That having a 4-day event is a lot of information. And again, I hope this information is something that you find to be useful. So I want to give you that perspective. Now, why should anybody pay attention to the data lakehouse? And I've got a lot of answers to that, but I've got one really good answer. And the really good answer of why somebody should pay attention to the data lakehouse is because of the fact of opportunity. That with the data lakehouse, we have the opportunity to start to do analytical processing that we could never do before. And what does that mean? That means that your organization has in front of it the opportunity to make better business decisions, to do things with business they've never been able to do before. So that's now there's a lot of other reasons why the data lakehouse makes sense, as in any evolution. In any evolution, there's a lot of reasons why an evolution occurs. An opportunity is hardly the only reason why we should pay attention to the data lakehouse. But as far as I'm concerned, it is the most important opportunity. One of the things that you're going to find when we get into this is that data lakehouse involves a new set of skills. And again, it's part of an evolution. And the skills that you may have learned previously in your career, it's not that those are bad skills. It's not something we're not saying anything negative about the things that came from the past, but a new set of skills is what we are looking for. I liken this to finding gold in California. In 1849, the world found out that they could go to California and find gold. And so how did gold mining progress in California? Well, when the first people came, it was easy enough to take a pan and go down to the stream and try to find gold. And in fact, they did. But they found that it wasn't terribly efficient, and they found that it was hard work to go down there. So the next thing they found was let's create something called a sluice box. And a sluice box was a much more efficient way to find gold than trying to pan it. And then they just discovered that, we ought to try other things. There's a lot of gold here, but we've got to move a lot of earth. And they tried something called washing. Washing, they had these huge hoses in which they would aim the hose at the mountainside, and the mountainside would come down, and they would take what came down and search for gold. And despite the fact that the environmentalists didn't like that, it nevertheless was an efficient way to mine gold. And then they discovered that they could go in and dig into the mountains. So what we find is that the tools of discovering gold evolved over time. And we find the same thing with the data lakehouse, that the tools of yesterday are still useful tools, but we're going to need a new set of tools as we go forth. So I wanted to bring that analogy to you so that you understand what we are talking about here. So anyway, with that, let's go ahead now and begin our presentation on the data lakehouse and the basic elements. So I want to begin with a simple diagram, and yet it's one of the more profound things that we'll be talking about. Let's start with all of the data in the corporation. So this orange box on top says that we have everything that goes on in the corporation. When we take a closer look, all data in the corporation can be divided into structured, textual, and machine-generated data. When we look at these types of data, each of these types of data have their own unique set of characteristics. And the type of data that most people are familiar with is structured data. However, there's other important data in the world as well, textual data and machine-generated data. So in case you're not familiar with structured data, which almost everybody is, let's have a quick overview of structured data. Where does structured data come from? Typically, transactions, banking transactions, point of sale transactions, telephone calls, payments made, payments received, and the kinds of things we expect to find when we go into a structured environment are such things as keys, attributes, indexes, and records. And these are the kinds of things that we expect to find in the structured environment. And the structured environment has been around for a long, long time. Why do we call it the structured environment? The reason why we call it the structured environment is that the structured environment the structure of data is the same from one record to the next. What changes is the contents. So if I were to go into the bank and withdraw $500, and you were to go into the bank and deposit $50, our records from a structural standpoint would look exactly the same. The difference is that the content of the record would be different. My record would show my account and a withdrawal. Your record would show your account and a deposit. So this is what the structured environment looks like. The second environment that we need to contend with is the textual environment. Now, text is not nearly as well known or understood as the structured environment. But where do we find text in the world? We find it everywhere. Text is more pervasive than any of the structured environment. Where do we find text? We find it in medical records, contracts, internet, call centers, warranty claims, insurance claims, email. There are lots and lots of places where text exists in the corporation. What we find is that there's a lot of complicating factors for dealing with text. The first complicating factor is language. Text comes in different languages. We have English, Spanish, Portuguese, French, Mandarin, Korean, German. We got lots of languages out there, and each of the languages have their own set of rules that make up their text. The second complicating factor is formal language. We have people. If you're a writer, if you've written a book or write an article or whatever, there's a way that you write it, and that's called a formal way of sentences, of verbs, of words that you can say, words you can't say, and things like that. And we also have slang, and slang is a form of communication, is a form of words, but it doesn't obey the same set of rules as formal language. And we have acronyms. These are some of the things that make text complex. Another factor we have to take into account when we deal with text is we have voice information, We have written information. We write a report out or we write an article out. We have the internet. We have video and so forth. So these are now, whereas most people are familiar with the structured world, most people are not familiar with the textual world. It turns out that there is technology that allows you to take text and turn it into a structured format. And when you do that, you are able to do analytical processing. The third type of data, the one that people are now exploring, is machine generated data. What is machine generated data? Machine generated data is data that comes from somehow a mechanical device. And so, what are some of these mechanical devices? They're things like drones, electric eyes, temperature gauge, things that measure speed, things that are mechanical, telemetry, and so forth. So let me give you a couple of examples of machine-generated data. When it comes to machine-generated data, I hearken back to the ranch in Texas that I grew up on. Years ago, the railroad company came through my father's property and ran a line over part of his property. And the arrangement he had was that every time a train came by, my father got paid, I think it was a nickel or something like that for each car. But they had an electric eye sitting there waiting. So when the train came by, the electric eye sat there and counted the cars. And that's how they knew how much to pay my father. That's one example of machine-generated data. Let me give you another example. Another example of machine-generated data comes from manufacturing. For a brief while, I worked in a steel mill, and in steel mill, I don't know if you've ever been a part of how steel is generated or created, but they have all of this raw material that goes into a melting pot. They heat it up to I don't know, 2,000 degrees or some very high temperature. It becomes molten, and then they roll it out. Well, as they roll it out, there's an electronic eye that sits there and measures the steel. Every 12 inches or whatever the engineer decides needs to be measured, the engineer looks at such things as the temperature, the chemical makeup, the width and strength of the steel, and so forth. And so we have a mechanical device sitting there looking at information being generated. Let me give you a third example of the machine-generated data. A third example of machine-generated data comes from surveillance cameras. So you can imagine a parking lot. It may be the parking lot that your company has or anybody's parking lot, and there is a drone, a machine that sits there and views the parking lot throughout the day. Now, 99% of what the camera sees in the parking lot is not very useful information. It's just cars sitting there, and that's not terribly useful. Where it becomes really useful is if somebody decides to break into a car or come along and do some kind of damage to the car, then that information becomes very useful. But when you stop and think about it, 99% of the data on a surveillance camera is not interesting data. 1% or even less than 1% becomes very interesting data. So that's what happened. That's an overview of what we're going to see when it comes to machine-generated data. Another example of machine-generated data is telemetry. Here we see a rocket taking off, and it's kind of interesting. When I began my career, I worked at a place called White Sands Missile Range in New Mexico, and in White Sands, we used to occasionally shoot a missile into White Sands. It's a large expanse, and nobody's there, and it's a good place to shoot a missile. But what do scientists study when they study a missile shoot? Well, they have on the missile something called telemetry. And what is telemetry? Telemetry is an automatic machine-generated way of describing the flight of the rocket. And what does the scientist look at? The scientist looks at such things as the speed of the rocket, the location of the rocket, where the rocket lands, the height the rocket has gotten to. And so you can think then again of a machine generating lots and lots of information for the scientists to study when they are looking for valuable pieces of information. So the data then that we find coming from the structured world is very different in terms of its form and structure of data coming from the world of machine-generated data. And so this is when we go to start to take a look at the data lakehouse, we need to keep in mind the fact that we have all of these different kinds of data that need to be blended together. And here we see that we created something a while back called the data lake. And the idea behind the data lake was simply to take all of this data and throw the data together, that we just take it, put it out there, and then the user can come along and use the data. That was the idea behind a data lake. Now, a data lake, in a lot of ways, is a good idea. Having data that people can use and look at and work together with is a good idea. However, it turns out that when simply throwing data into a data lake turns your data lake into a swamp, that people find out that, gee, there's more to this than simply throwing data into a data lake. And so you don't want your data lake turning into a swamp. What are swamps like? Swamps are smelly. Swamps have alligators and snakes and all kinds of things that you really would rather not to be involved with. And so, again, the initial thought of a data lake, of putting data into a place where people can get to it, was a good idea, but it was very bad in terms of execution. So this is where a data lake came from. The data swamp really wasn't good for anything. It starts after a while to smell. It's an expensive exercise for the corporation that the corporation doesn't really benefit from. So what we need to do is to turn our data lake into a data lakehouse. And so that's what we're going to be talking about for the next 4 days. And that's something that that we'll be spending a lot of time on. So I want to kind of change this. I need 1 second. I need some water. Thank you. I'd like to change the subject a little bit. Let's talk about the people that need to use the data lake. There's a lot of users of the data lake, but one of them, and perhaps the most important one of them, is the data scientist. The data scientists find that there's a wealth of information in their data lake. But let me tell you a little thing that I've found talking with data scientists, and I've talked to many of them over the past several set of years. Over and over, the data scientists say, Bill, I go to school, I get all of this education, I learn about statistics, I learn about algorithms, I learn about an analytical processing, and I go to school to learn all of this stuff about data science. And when I get into the real world, I find that 95% of my time is spent being a data garbage man. I only use my data science background 5% of the time, but 95% of the time, I'm struggling with finding data, cleaning data, getting the right data, trying to match data. And so we find then that we give data scientists all of this education, but at the end of the day, we don't even allow the data scientists to do their job. So a precursor to success in the data lake is the ability to build the infrastructure of the over the data lake. And once we build the infrastructure over the data lake, then we can call it a data lakehouse and start to do some analytical processing that is, quite frankly, potentially very valuable to the corporation. So that, from an evolutionary standpoint, as far as I see it, is how we get from the data lake to the data lakehouse. And now, I want to give you a word of caution. And the word of caution is that as we go to look at the data lakehouse, there's a lot of complexity involved. When I say a lot, I mean a lot of complexity involved. Anybody thinking that this is going to be an easy exercise is in the wrong place. If you want something nice and easy and smooth and uncomplicated, you don't need to be in a data lake or a data lakehouse. So that's a little bit of information about the data lakehouse. So now let's talk about one of the properties of machine-generated data, about how do we start to take our machine-generated data in the data lakehouse. How do we start to organize our data so that we can use it efficiently and effectively? And I want to give you some basic ideas. And this is really basic stuff. This is not really anything new, but it's something that you need to be aware of. When you take a look at the vast majority of the data that's being created for the data lakehouse, there's a lot of data that's being created. What we need to do is to divide our data into two camps: high probability data and low probability of data. High probability of data is data that's generated by a machine that has a high probability of being useful, as opposed to data that has a low probability of being useful. And what we're going to do is we're going to place our high probability of data in a high performance environment, and we're going to take our lower probability of data and place it in a bulk storage. Now, the fact that we place it in bulk storage does not mean that we can't get to it if it's needed. If it's needed and we need to go look at it, then it can be accessed, but it's more expensive and less efficient to access data in bulk storage than it is in high performance storage. So this is the split, the architectural split of data that we're going to make in order to facilitate people being able to do analysis on machine-generated data. So as an example of what we mean by machine-generated data, generating a lot of data and then making the division, if this were a rocket shoot, if this were telemetry, we would find that high probability of data would be information such as the date of the launch, the ultimate speed, the ultimate height, and final landing point. That whoever's studying this data is ultimately very good chance that they want to find those types of information. So we're going to take those types of information and put them in a high performance environment. The other data generated by the rocket going into the earth, into the sky, is we're going to have a lot of second by second measurements. Now we're going to put this data in bulk storage, and this is how we're going to divide our data. And pretty much all machine generated, I hesitate to use the word all, because the minute that I do, there's going to be somebody with an example that doesn't hold true. But nearly all machine-generated data can be divided this way, between high probability of access and low probability of access. Now, another thing that I want you to understand about data in the data lake and the data lakehouse is that there is not an even division of the data when it comes to the size of the data. From a volume standpoint, structured data represents the lightest volume of data that you're going to find. It's the smallest amount of volume. Textual data represents even more volume than what we find in the structured world. And machine-generated data is even more than what we find in either the textual or the structured environment. So there is this relationship of the different kinds of data that we need to understand. Now, this slide here, as far as I'm concerned, this is the most important slide you're going to see from Bill Inman in this symposium. But let's talk about business value and the volumes of data, because there's very different types of business value that we find in these different environments. First off, let's go to the structured environment. When you take information such as telephone calls, banking transactions, point of sale transactions, and things like that, you find that in one form or the other, pretty much everything, not everything, but pretty much everything that you find in the structured world has business value, or at least the potential of business value. Yes, I'm sure that there's some types of structured data that don't have any business value, but quite frankly, nearly all structured data has business value. Now let's go to textual data. When we go to textual data, we find that indeed there are some really, really valuable parts of textual data that have great business value. But there's other parts of textual data that don't have a great amount of value. And so let's take a look at that. Let me tell you an anecdote here. A while back, we were looking at the emails that Enron, the corporation of Enron, has put out on the internet. For a variety of reasons, the federal government required Enron to put the last 600,000 emails of the corporation out on the internet for anybody to look at. I don't know why they did that, but that's I'm not a lawyer either. But at any rate, if you're ever looking for a bunch of emails to look at and process and whatever, and some people do need to find emails are hard to find. I don't know if you know that. I don't know a corporation out there that would you knock on their door and ask for email, they're not going to give it to you. So the fact that Enron has all of these emails out there on the internet, that's kind of an interesting fact if you need to work with emails. Well, what do you find when you take a look at the emails that Enron did? You find that indeed some of the emails were done for the purpose of business. Absolutely, yes, they were. But quite frankly, maybe 40 to 50% of the emails in Enron was somebody telling a joke or somebody talking about their local football team or baseball team. And so in terms of business value, there were probably at least 50% of what went on at Enron didn't have any business value whatsoever. Now, again, so what we see then when we compare structured data to textual data is we find that there is a real difference in terms of how much data is truly valuable to your business. And then we go over to machine-generated data. And what we find in machine-generated data is that there's a lot of data created by machine that doesn't have any real business value. However, there's some data created by machines that have great amounts of business value. And so this is another way architecturally of looking at the differences between the different types of data that we find in the data and the data lakehouse. So, and now I have to tell you, I've been working in this for a while in terms of elucidating slides. I think this is my favorite slide. This because we're going to find later on that this slide explains a lot of things that we need to do architecturally. So I would ask of you to please remember this slide as you're looking forward into architecture. Now, let's now talk about doing analytical processing across all of this data. There's actually a lot of components to analytical processing. And one of the components is format capability. And so you've got data in one format. By the way, there's a lot more to it than format capability. If we're going to do analytical processing across the organization, we need to do a lot of things. And certainly the format is one of them. But as we're going to see, it's not the only one at all. There's a lot of other things that we need to consider. But from a standpoint of taking structured data and textual data using textual ETL, we can now take textual data, put it into a simple relational format. And so from a standpoint of format, the structured data environment and the textual data environment are actually extremely compatible. However, we go over to the machine-generated environment, and in the machine-generated environment, we find that the format of data in the machine-generated environment normally is very different from the format of data from the structured and the textual world. However, formatting is only one of the ways that we need to organize data to do analytical processing. And so we find then that as we start to do our processing, trying to mix and match structured data with textual data, with machine-generated data, is something that is not at all easy to do. Let me give you an example. In the structured world, we have things like keys, attributes, and whatever. In fact, that's really kind of what the structured world is. But in the textual world, we don't have that. People talk and people write. And I don't remember ever having a conversation where somebody in the world of conversation talks like somebody from the structured world. People don't talk in terms of keys, key values, attributes. That's not how people have a natural way of talking in the textual environment. So the very fabric of data in the structured environment is very different from the data found in the textual environment. Now let's go to the machine environment. Here we find also that the information that we have in the machine environment is information that is very different from the information that we find in the other environments. And in order to do analytics, there must be some common data on which to do a comparison. Without common data, it's very difficult to do a meaningful comparison of data. And this is a real challenge for data found in the data lakehouse environment. The problem is that there's no obvious, easy way to isolate common identifiers, that the information we find in the structured environment is different from the textual environment, is different from the machine-generated environment. However, the good news is there are some things as very broadly defined universal common connectors. So you ask the question, gee, Bill, I've got all of this data in my data lakehouse. How do I meaningfully bring this data together? First off, can it be done? And second off, what does it look like when we do it? And so the universal common connectors that I'm going to be discussing with you today exist regardless of the way that data has been collected, stored, and organized. So what is a universal common connector? The most basic universal common connectors are geography, time, and in most cases, dollar amount, that you can almost always connect your data on these. So what do we mean by geography? That when we have transactions in a bank occurring, it always occurs at some place. When we have textual data occurring, somebody is somewhere sitting in a chair or in a phone booth or wherever they're at, there's always geography associated with it. Machine-generated data, the machine is always somewhere. So geography is one way that we can start to have commonality among the data. The second thing is everything has a moment of time associated with it. A transaction has a moment in time in which the transaction has occurred. A text has a moment in time when two people have talked together or had an email conversation. In terms of machine-generated data, whatever we're generating with the machine or whatever we're measuring always has some moment of time associated with it. The third thing that doesn't always hold true, but usually holds true, is dollar amount. That when we talk about a banking transaction, there's a dollar amount associated with it. When we talk in terms of text, oftentimes, but not always, oftentimes there's a dollar amount that's mentioned in whatever we're talking about. And in terms of the machine-generated environment, there's usually one way or the other that we can associate a dollar amount with it. So these three things, geography, time, and dollar amount, are universal common connectors that can be used to connect and organize our data in the data lake and data lakehouse environment. Now, there's another set of universal common connectors. If we happen to be talking about humans, and sometimes we are, sometimes we're not, but if we happen to be talking about humans, then there's actually a fair number of universal common connectors for humans. Gender, age, race, body weight, things like that, so that every human being has a certain set of characteristics that they have that they share with everyone else. And so now again, all data isn't about humans, but when we are dealing with humans, indeed, there's another set of universal common connectors. And then if we're talking about physical objects always have weight, color, cost, size, shape, and things like that. So that then is the example. So you say, okay, Bill, thanks for telling me about this. This sounds a little bit different from anything I've ever heard. Can you please give me some examples? So I'm going to give you some examples. Let's start with healthcare. First off, everybody around the world, doesn't matter what country you live in, doesn't matter who you are, everybody needs to have healthcare. That's a universal common need. And improving healthcare is something that is going to help everybody. So one of the things that they attempt to do in healthcare is something called outcome analysis. And what is outcome analysis? I don't know if you know this or not, but if you go to a doctor and a doctor prescribes a medication for you, is the doctor certain that that medication is going to work for you? And the answer is no, the doctor isn't. The doctor's doing their best to give you the best treatment that they can give you. But in terms of the outcome, in terms of what the medicine's going to do for you, it's not certain. Most of the time, thankfully, medicines work and work as the doctor thinks they're going to work. Occasionally, the doctor prescribes a medicine, and for a variety of reasons, the medicine does not give you the results that you would like to get. So this is what's called outcome analysis. We can improve medicine. We can make our doctors more effective by saying that when this medication is given, this is going to be the result. Did the medicine work? Did the vaccination work? Did the operation that the doctor gave you have the right effect? And again, most of the time, thankfully, the answer is yes, everything turned out all right. But when the doctor does what the doctor does, it's almost like an experiment. And again, this is what doctors do. Believe me, I'm not complaining about or saying anything negative about doctors, but does a doctor actually know what's going to happen? The answer is no, they don't. So the doctor can improve the way they do their medicine by understanding the outcome of what they do. But understanding the outcome of medicine turns out to be a very difficult thing to do. So let's take a look at what we expect to find in our different environment. As an example, and this is just, by the way, this is just one example. What I'm going to be describing to you is one of many, many different ways of doing this. In the structured world, we have things about sales. So we can find and track the sales of medications such as Prolia, estrogen, vitamin D, Algical, calcitonin, and there are thousands of medications out there, and we can find and track the sales of that. Then we can go into doctor's notes, and we can find out what the doctor has said over lots and lots of patients. We can find out such things as what tests have been done, what diagnosis has the doctor made, what procedures have been tried, medication, the history of the patient, so forth and so on. And then, if we want, we can go into the world of machine-generated data in healthcare. And that would include such things as x-rays, sonographs, MRI, the date of the treatment, location, patient age, examination results. These are the kinds of things that we can expect to find associated with mechanically generated data. So what can we do when we organize things by state? We can say, okay, for the state of Utah, what medicines have been purchased? And for the state of Texas, what medicines have been purchased? So we can organize our structured data by state. We can also go into our textual data, and our textual data by state. What were doctors in Texas finding? What were doctors in Iowa finding? What were doctors in Pennsylvania finding? So we can take our textual data and organize it by state. And then we can go into our machine-generated data by state. What has been found in terms of an MRI? What's been found in terms of ultrasound? What's been found by sonography, by radiology, etc., and so forth. So we can go into our different environments by state. Now we can also, because we're dealing with people, go in by age. We can say, what medicines have been prescribed by people that are 20 to 30, 30 to 40, 40 to 50? What medicines have been described is one way of looking at it by age. We can also go into what our doctors have found, our doctor's notes by age. Have the doctors found a difference between people having information about their medical health, difference between 30 years old, 40 years old, 50 years old, and so forth. And we can do the same thing with the machine-generated data. We can take the machine-generated data and say, was the machine-generated data for someone, and what age was it for? So that's another way of looking at our data. Another way of looking at our data is by gender. And certainly when it comes to disease and medication, women, well, we all know that women and men are different, but in terms of how they are treated, how they are responding to and treated to medications and procedures, yes, there are differences between men and women there. And so by gender, we can look at when women take a certain medicine, what results are achieved. When men take a certain medicine, what are the results achieved? And is there a difference by gender? The same thing for textual information found in medical records. We can say, what are doctors finding in terms of medical records for women? What are doctors finding for men? And we can do the same thing for our machine-generated data. So you see, we can go across these different types of data with something as common as geography, age, gender, and so forth. And the insights that we can find here are extremely valuable insights. So what kind of analysis might we be able to do when we have this data connected and organized by these universal common connectors? The answer is we can do analysis that is truly amazing. For example, we can ask such things is how does treatment from COVID differ in Utah from treatment in Oregon? And once we understand how the differences are, how people in Utah are treated versus the people in Oregon are treated, we can then draw some interesting conclusions. We can find out that, some of the things we're doing in Utah are more effective, perhaps, than the things we're doing in Oregon. A second question we can ask is the drug Prolia more effective than estrogen? Or when patients are treated with Algical, what other side effects are noticed? There's a wealth of information that can be generated from using common connectors across the different types of data. So that's what we expect to find when we are dealing with the types of data in the data lakehouse. When you have the opportunity to have both treatment and outcome data together, you can answer really for the first time important questions about treatment, medication, dosage, side effects, demographics of treatment. And what happens when we have this kind of information? What happens is doctors get to be a lot smarter about what they can do to treat a patient. And who benefits from this? Well, everybody benefits from this in terms of having better health. So the result is healthier people, longer life, and better quality of life. And I don't know. I'll be honest with you. I don't know anything better than that. If somebody can think of a more worthy goal than this, I'd like to know what it is, because improving the health of people on Earth is a pretty lofty goal. Now, we talked about the world of healthcare. Now let's talk about the world of manufacturing. The world of manufacturing is completely different from healthcare. However, when we go to manufacturing, we do have information about things that occur in manufacturing. For example, structured data, we have sales data. What has the manufacturer sold? When it comes to textual data, we have warranty claims. Turns out that there's a wealth of information in warranty claims, by the way, that most corporations don't pay any attention to, and that's a shame. When it comes to machine-generated data, we have lots and lots of machine-generated data. I hearken back to a semiconductor manufacturer that I worked for briefly, did some consulting for, and the machine manufacturer, I was amazed to find this machine, this manufacturer produced semiconductor chips, and the information that they stored and could have on the chip was absolutely amazing. That in terms of what operator created it, what lot the part was created in, I mean, it was amazing the information that exists about each individual item. Now, mind you, the manufacturer is creating millions and millions of these chips on a daily basis, and the fact that there's unique individual information on each chip is simply it blows my mind. It really does. So we have then the ability to have information about manufacturing in our environment. So what can we do to start to tie this data together? And what we can do is, among other things, we can look at the ID of the part itself, so that in the case of a semiconductor manufacturer, each semiconductor that's created has a unique ID, and we can track that across our environment. And when we do, we find that we can do some analysis that's really amazing. For example, we can look at what manufacturing machines are producing defects. We can find out what operators are producing defects. We find out what telemetry information needs to be adjusted. We need to find out under what conditions are defects created. And by improving our manufacturing process, this makes our company a much more efficient organization. And how do we get this information? We blend the information from these different environments together to create a picture that is very useful. With all of this data together and the ability to be analyzed in the data, we can now tell what defects are corrected and what conditions cause defects to occur. And believe me, if you're a manufacturer, knowing what the cause of defects to occur is very valuable. I'm not sure it's the most valuable thing there is, but it's got to be close to the top of the list of what would a manufacturer like to be able to find out, and that is how to create their product without defects. So now manufacturing can be done efficiently and in a cost-effective manner. So this then is a little bit about the structure and content of the data lakehouse. We're going to be hearing a lot more. Now, I want to quickly jump over and do another presentation for you. And this is a question that I get asked all the time. I wish I had $1 for every time I've been asked this question. Is a data lakehouse the same thing as a data warehouse? And I hate the answer I'm about to give you, except that it's the truth. And the answer is sort of. In some ways, the data lakehouse is like a data warehouse. In other ways, it's very different. So again, I don't like to give you an answer of sort of. That's sort of is not a very good answer, except that it's the truth. And so I'm not going to lie to you. So let's now examine a little bit about the different environments that we're bringing together in the data lakehouse. First off, let's talk about data warehouse. I don't know, and I don't want to be, most of you probably are familiar with data warehouse, so I'm not going to belabor the points, but I do want to talk a little bit about what a data warehouse is so you understand it. Here we see applications, and in the applications, they've been created over the years. We take the data from the applications and pass it through something called ETL, extract, transform, load processing. In doing so, we transform the data into a data warehouse. So if there ever were, I can't tell you how many times this particular diagram has been repeated in business. I see it over and over again, and so I can tell you that this is the truth. Now, what most people don't understand is we're not just moving data into a data warehouse. We're making a fundamental transformation of data. And so as an example of what we mean by a transformation of data, over here on the left-hand side, we have application. And one application has specified gender to be an M or an F, and distances to be measured in inches. Another application has specified gender to be measured as male and female, and the distance of whatever we're measuring is in terms of feet. The third application has gender as a 1 and a 0, and distance measured in centimeters. As we go into the data warehouse, we have to transform this data. We have to determine how we want to have a singular understanding of our data. We choose gender as being an M and an F, and that means that when gender's male and female and a 1 and a 0, that we have to make a conversion. Now, this is a simple conversion. In truth, most conversions and transformations are much more complex than this. But this gives you the idea. We're not just moving application data into a data warehouse. We're making a fundamental transformation of data. So what is a data warehouse? A data warehouse is subject-oriented, integrated, non-volatile, time-variant measurement of data. It's a collection of data for management decisions. This has been the definition of a data warehouse from the very beginning. And what does the data warehouse entail? Another way of thinking of the data warehouse is it's the single version of the truth. That's what a data warehouse is. One of the other features of data warehouse is that it contains historical data. Prior to data warehousing, data wasn't stored for very long periods of time. But with data warehouse, we could discover that we could store data for a lengthy period of time. Data warehouse is, for all practical purposes, based on structured transaction-based data. That's what we think of when we think of a data warehouse. Now let's go to the data lakehouse. Here we find a data lakehouse, and we're going to find that the data lakehouse has some characteristics of the data warehouse, but it has other characteristics that are only found in the data lakehouse. The first thing that we find that's different about data that's stored in the data lakehouse is that for the most part, it's machine-generated data. There's a lot of machine-generated data there. And as we've talked, a machine-generated data has a whole different set of properties than transaction-based data. So the second thing we find is machine-generated data tends to be very voluminous when it comes to creation. Those machines sit there and generate data faster than we can ever imagine. So the volume of data that's generated by machine-generated data is something that is simply enormous, and much more data generated by machines than ever generated by transactions. The other thing that we find when we look at machine-generated data, as we have discussed, is that there's some machine-generated data that has a great amount of business value, but there's a large volume of machine-generated data that has very low business value. So we now then find that we take all of this data and put it into a data lake. And when we do so, we are wise to segment the data. We're wise to separate out the data that has a high probability of access from data that has a low probability of access. What we need to do in order to turn our data lake into a data lakehouse is create an analytical structure that's being placed over the data. That's really what we're doing. Is we're starting with a data lake, and then we're putting an infrastructure over the data lake that allows us to make sense of and use the data found in the data lake. So here we see a data lakehouse and a data warehouse. Are they the same thing? Are they different? And again, I hate this answer, but the answer is sort of. The data lakehouse does carry some of the characteristics of the data warehouse, but the data lakehouse also carries a set of characteristics that are unique unto itself. So now let's talk a little bit about the data lakehouse and the data warehouse. How are they the same? Well, they both exist to serve analytical processing. That we need the data in there to discover how we can run our business together. They both have vetted data that's accurate and reliable, that if you find data in the data warehouse or data in a data lake, you make the assumption that it's accurate data and that you can start to use it for analysis. They also look at data over a lengthy period of time. The data lakehouse is ideal for storing data that's 2 years old, 5 years old, 10 years old, etc., and so forth. And so is the data warehouse. They both have time variant data. That is to say that the units of data in the data lakehouse and the data warehouse have a moment of time associated with it. They have data that once recorded cannot be changed, at least with accuracy. So when a machine generates its data and spouts it into the data warehouse, we don't want to go back in and change that data because that's what the machine thinks the data is as of the moment it's captured. And the same goes for the data warehouse. So indeed, in certain ways, the data lakehouse is the same thing as the data warehouse. However, there's a whole set of differences between the data lakehouse and the data warehouse. And so there's much more data in the data lakehouse than we'll ever find in the data warehouse. And so volume of data is one of the considerations that we have when we go to the world of data lakehouse. Number two, the data is fundamentally different. Data warehouse data is transaction-based data. Much of the data in the lakehouse is machine-generated data. And machine-generated data is fundamentally different from transaction-based data. Another thing, the data structures are different. How we organize and store our data in the data lakehouse is, quite frankly, different from how we think of and store our data in the data warehouse environment. And then finally, relating the two types of data is difficult to do. We've talked already today about universal common connectors, and that's a good way to start to unify our data. But if you stop and think about it, geography, time, and dollar amount, as important and as valuable as those things are only scratching the surface of how data can be organized and analyzed. So this is between, and I want to try to back up here. In some regards, the data lakehouse and the data warehouse are very similar. In other regards, the data lakehouse and data warehouse are very different. And that's why I give you the answer that I don't like to give you. Is a data lakehouse the same thing as a data warehouse? And the answer is sort of. I liken it to putting two cousins in the same room together. If you have a family, and everybody has a family, if you have a family and you put two cousins together, what do you find? Well, you find that there are remarkable similarities between cousins in terms of the way they look, in terms of the color of their hair, in terms of their ethnic origin, in terms of having similar features. Two cousins are remarkably the same and look the same. However, there are differences. Here we see two cousins. One is a boy and one is a girl. And guess what? They're different. But if we were to go into their DNA, we would find that indeed they share a lot of common DNA, but they also share distinct DNA. And so this is what we mean by when we compare the data lakehouse to the data warehouse, this is the comparison that I like to make. Okay, now we're going to go off on a different tack. I have told you that the data lakehouse has many different components. We've got violins and cellos and flutes and pianos and drums. We've got a lot of instruments in, a lot of things going on in the data lakehouse. And the rest of this symposium is going to be about the different components. And so I want to introduce to you a gentleman, Robert Scott, who's a professional colleague of mine, who's going to talk about one of the differences or one of the components of the data lakehouse.
Well, thank you, Bill, for the introductions and also for the walkthrough on the data lakehouse. A lot of what Bill has gone through, I've learned over the years and so forth, and I feel humbled and appreciate the opportunity to go through a aspect of the data lakehouse. And we're going to talk to you today about data lineage in the data lakehouse. I want to also thank Databricks and so forth for sponsoring this presentation. So who am I? Just to quickly, I am the Chief Technology Officer of Eon Collective, a dear colleague of Bill and Min, pretty well known in the space for my in data modernization, lineage, governance, and complex migrations. But today it's not about me. Today it's about the data lakehouse and our journey of utilizing the data lakehouse and getting at aspects of what's in the data lakehouse. Where's my cheese? Where did it come from? And a lot of that has to deal with data lineage. So in order to understand lineage, we have to understand the journey. And in order to understand the journey, we have to know where we're journeying to and where we came from. You have to know the ancestry, right? The heritage of where everything started from. And a lot of opportunities, a lot of the projects and so forth that are out there today, when it comes to building out a data lakehouse and so forth, building your lakehouse with Databricks or what have you, it's a modernization journey. Modernization is really just taking those things that we now call legacy, where a few years ago they were modern, right? But where we've adapted them and they've grown over time and so forth. And there's new ways of doing things better than the way we've done it before, faster, better, cheaper, as they say. And what we want to look into is that when you go through that modernization, when you're moving things from your traditional data stores and your traditional systems, and now you have this thing known as IoT and all this other kind of stuff and streaming and moving to the cloud. Well, how do I get that into my data lakehouse? And ultimately, how do I know where I came from? Well, in order to get there, Bill talked about a couple different things in his presentation, right? Bill talked about structured data and unstructured data and textual data and machine data and all these other things that are out there. And if you have gone through Bill's book, his latest book on the data lakehouse and so forth, it talked about how you would utilize those things and how they make sense within your lakehouse architecture. And it talks about, in the chapter on data lineage, it talks about identifying certain things about the things that you're trying to capture in your lakehouse as what relates to lineage. Well, we have traditionally known that as about metadata of the information that we have. So in order to understand what I'm going to talk to you about with regards to lineage, we first need to understand information about the data that we're actually looking to place in our lakehouse and so forth as well. And that's metadata. Classic term of metadata is what? Data about data, or information about what you're trying to do in. And we need to understand that aspect of it. It's very dynamic. Metadata management and proper metadata management should provide the following insights. How does a data element move from one location to another? How do two or more data elements depend on each other? And how does the profile of a data element evolve along its journey through the different environments from where they came from? Well, if you want to know the answer to these questions, there's a certain aspect of our technology and so forth that allows us to be able to see that transition over time. And that is where lineage and the lineage architecture that I'm going to talk to you about today. Now, first and foremost, if you look at this picture on the left-hand side, you see a bunch of things here. You see BI information. You see information that's in the cloud. You see reports. You see information that's coming in different storage mechanisms, information that's coming off of servers, information that's coming off of models and so forth. Just a bunch of information. As as the technology grows and evolves over time, all of these things are the ecosystem that make up complexity. Lakehouse architectures pull data from a myriad of systems and data types, right? we started out back in the day for batched information. Then we heard a thing called near real time. And then we heard of a thing called real time. And then all of a sudden, like I said, there's this IoT and streaming data and so forth. What did Bill call that? He talked about it as being voluminous and variety. You know, the traditional big data aspects of it, but it's evolved. Big data ain't big anymore. What we have and what we need to understand has to be stored in a mechanism such as the lakehouse. But when you have the agile in the agile world, and you can move these things so quickly into your lakehouse and so forth, now certain things start to come to fruition. If I'm a data, look at the personas. If I'm a data scientist, if I'm a business analyst, if I'm a developer, if I'm a consumer of that data and so forth that's there, don't I need to understand the information that's in my lakehouse? Well, without that metadata and without the information around where it came from, the data lineage is the key to your data lakehouse. Now, hopefully you guys can still hear me on the other hand, but now I'm going to start relating what is data lineage as it relates to the data lakehouse. And traditionally, as I talked about before, it's a journey. It's capturing the journey of your data from the source, which I call the ultimate source, to its ultimate target. And the ultimate target is depending on the view of that persona. Ultimate target may be a report. Ultimate target in certain case may be a table where that information resides. Ultimate target may be an extract that it went to. No matter where that information goes, ultimately it's a flow of that information along its way. But real data lineage is far more than that. Data lineage represents a detailed map of all the direct and indirect dependencies between those data entities in the environment in your lakehouse. And what that ends up looking like is we're going to shed a light on what do you typically need to consider when you're looking at data lineage in your lakehouse. Now, I have to say that Bill does a great job of this in the book, and I actually went back and took another look at it, and I was like, he explains those things. What are the things to consider? You know, the chain of calculations over time. What is that? Well, think about a commission, a broker's commission. Think about a report that you may have. You may have a report that's running off of your Databricks data lakehouse or what have you, that's in Tableau or ThoughtSpot or whatever reporting engine and so forth that you have out there. You may be utilizing that's out there. There's calculations that make up that particular report element that you're looking at. My calculation for my check has a lot of different aspects of it. It has taxes, it has FICO score, there may be fees and so forth that are there. Well, if I'm going to be audited, or if somebody's going to ask me, in order for me to trust the information that's in my lakehouse, in order to get your business, if I'm an IT person and I'm giving a report to the business, how is the business going to trust the information that's there? In some of our follow-on presentations, we're going to talk about things of, cataloging and other aspects of text. A dear colleague of mine, Patty Haynes, is going to talk about data governance and all those other kind of things. But one of those core components and so forth of that is is lineage, which kind of ties those things together. The selection of data. Do you have insight into all your corporate payments? If I'm a C-suite, CEO, COO, Chief Revenue Officer, CFO, if I'm a executive manager and so forth, and I'm providing reports, how often have you heard that number doesn't look right? How was that number calculated? Why are my numbers different? Wouldn't it be nice where you don't have to go back to a subject matter expert to ask those things? and it takes weeks or months and so forth for that information to come. And by the time you got the information, you don't need that information anymore, or it has changed. How's some of your corporate payments been missed? How do you know? Now think about GDPR and CCPA and all those compliance things that are out there, where you're tracking privacy information over time, and where did that information come from? And for those that are on the call that understand about Article 30s and 45s and so forth, how are you even filling out the report if you don't understand where that information came from? Let alone the third point on here, which is your algorithmic differences. How was it calculated? For those that are in the insurance vertical that are on this call and so forth, you heard things about earned premium and written premium and all this other kind of stuff. Well, how often, if you go to your underwriters or your actuaries, or you go to another part of the business and they call the earned premium, but when you look underneath the hood and look at the report, they calculated it differently. That's where lineage comes into play. And especially in the data lakehouse, because if I'm taking information off of my machine systems into my lakehouse, and I'm taking information from my source corporate systems into my lakehouse, but the structured data, and let alone all the stuff that Bill talked about, textual information is becoming more relevant. Data is becoming, I saw somebody put a Q&A out there around data's new gold, right? That's out there. Well, if you have new gold, you better know where that gold came from. So the lineage for that textual information, the different environments that Bill talked about, structured environment, lineage for the textual environment, lineage of the other unstructured environment. I wish I could say I wrote this, but this is outlined in the Data Lakehouse book and so forth. And our folks at Databricks and so forth have the mechanism, those I've used, Delta Lake and so forth, to be able to store all those three different types of data and data assets. Now, I'm not going to talk about textual data and all the other kind of stuff as it relates to the embodiment of textual. There's another session that I would implore you guys to stay on to actually look at as it relates to that. But let me talk to you about what that actually looks like when we actually talk about lineage. And what are the traditional things and the benefits of this lineage as it relates to your data lakehouse? We like to call it adept. I want to have an adept environment to handle the nuances of where my information came from. And I want to be able to track that. I want it to be auditable, and I want it to be trusted. If a lot of you guys have been out there and looking at the different tools and so forth when it comes to quality and so forth, everything's about trust score nowadays. What's the trustworthiness of my information and so forth that's out there? Well, I ain't gonna trust it if I don't know where it came from. That's what my mother taught me. So adept is an agile design environment for process transformation. That's just a key word for us. Your lineage capabilities, your cataloging capabilities, your lakehouse and so forth has to be adept to all the new information that's being brought into it. And if you look at that, wouldn't you want to see a DAG? For those of you really look at a lineage, it really looks like a graph of where that information came from. But let's look at what that detail map and so forth can hold. Now, in building the data lakehouse, and for those of you that have the book and looking at page 192 and so forth on this, it talks about a specific use case. How does a banker's commission how is it calculated? And then the handling of that payment that must be calculated over time. So I think it talks about transfer fees and all this other kind of stuff that's there. And for those of you that hang on, I'm actually going to show you a live demo of what that would look like from a lineage perspective. Well, on top of that, what is the best subset to test those cases that will cover the majority of the data flow scenarios for your newly released pricing database app or whatever application and so forth that you have out there? Lineage is good for that as well. And how do you divide a data system into smaller chunks that can be migrated to the lakehouse independently without breaking other parts of the system? Wouldn't you know what the impact is For those of you that have had the benefit of utilizing lineage applications and so forth out there, everybody talks about impact analysis or showing the lineage. And impact analysis can mean different things depending on where you sit within the organization. As an IT person, impact analysis is how do you answer the question when your business says there's a change that's coming in a certain calculation? We already talked about that the volume and variety of information is changing. I know of systems that are out there that have 98,000 reports. How do you know what the impact of that one small change, whether I change the data type, whether I change the name, whether I change the calculation, whether I change the rule? How do I know what are all the reports that are going to be impacted by that? What are all the data pipelines that I have that are going to be changed by that? What are all of the people that are going to be impacted by that? For those that are in change management, right? If I am a manager and so forth, and I'm going through some sort of M&A or divestiture or migration to the cloud and so forth, change is a big thing in an organization. People don't traditionally like what? People don't traditionally like change. But if you can tell them, if I make this particular type of tweak or change in the calculation, here's what's going to be changed, so that your change management organization can be more proactive in what's coming instead of being reactive when your business and so forth is saying something's changed, I don't like what I hear, I don't trust the reports, I don't trust the information that you gave you. That is what being adept is being all about, and what the modern data stack is being utilized to avoid regulatory or other penalties and so forth by utilizing this type of technology. Now, if you're going through a migration, if I'm migrating to the lakehouse, you may be migrating. I think Bill talked about what's the difference between a data warehouse and a data lake. And and he was saying, well, there's certain similarities, and he talked about the two cousins and so forth. But if you really look at it, when I'm trying to move something into something new, we have to understand where we came from. I talked about that in the beginning. I need to know where I'm going to hit. It's the ancestry part of it on there. I like to know who my grandfather was and my great-grandfather, because I have their genes. There's some similarities and so forth out there. There's a makeup in my DNA, right? Well, in order to do that, traditionally, you have to understand your current state. And in understanding your current state, then I know where that information is coming from and where it's going to. We used to have source to target mappings. Everybody knows about ETL and ELT and all the, I'll call it buzzword bingo and so forth that's out there. But ultimately, no matter what way information gets from point A to point Z, we want to know nowadays how it was there. No longer are we in a environment where we can just shrug our shoulders and say, well, it's overwritten. I don't know what it was. That's not doable. The Lakehouse gives us the ability to store all of that information. The Lakehouse gives us the ability to be able to be performant of that information. The Lakehouse gives us tools to be able to move that information out and in and so forth in many different ways, to be able to handle all the different. There's no reason why we shouldn't have the ability to say, if it's in the Lakehouse, where did it come from? Lineage. Now, I talked about lineage as it relates to impact analysis, right? If I changed a certain thing, what are the things that are changed along with it? Think about the simple things. For those that are developers that are out there, and I'm creating my Python or notebooks or what have you. Well, you're impacting change. The data scientists that are writing creating models and training models and so forth, something's changing. We're doing that analysis, but ultimately we're putting in things within our pipeline that's going to affect change. And whatever we change impacts something, whether now or later. And sometimes we don't even know what those things that are impacted. I talked about that in the beginning. One of the things I didn't talk about is that typically when you're talking about modernization, remember in the beginning of this this deck, I talked about modernization, and in modernization and so forth. Sometimes you're going to new technology. In this case, I may be going to a lake house from a traditional. I'm using, like I said, I'm using Databricks and Delta Lake and so forth. And I have new BI tools that I'm using. I'm utilizing new data scientist tools and so forth that are out there. Sometimes I need to repoint existing existing ETL or reports that were reporting to your legacy system. I need to repoint them to the new lakehouse. Well, what's the impact? What am I changing? A lot of people don't even think about this. I can utilize lineage as an after fact, where after I've moved everything and so forth, I can use lineage to say, where did it come from and where did it go to? But can't you use lineage also to do an assessment? Why wait until later? Why can't I assess what's there and utilize that to compute the complexity of what it's going to take in order for me to migrate into the new environment? Forget about just table lineage and so forth that I'm talking about here, but that's your ETL. It could be Informatica, it could be Talent, it could be Glue, it could be whatever you have out there it could be whatever BI tool and so forth that's there. But if we look at what's currently there, assess what it's going to take to be able to move it, show what your lineage was before, show you what the lineage and so forth afterwards, as you're moving around the day, it becomes a tool that's not something that's just as an end. It's not a byproduct of tool. It's a must-have of your governance tool chest. And like I said, we'll have another session on governance and so forth at a later point in time. Now, getting back to when I started talking about metadata, right? Remember in the beginning, I talked about modernization. I talked about that metadata, and that was the key, right? That was one of the key things and so forth that you needed. And if you read in the book and so forth, Bill talks about the different environments and so forth, but across those environments, he lists a certain information that you're taking off of structured, unstructured, textual, and machine data and so forth that's out there. And one of the things it was like, hey, I want to capture the machine ID, and I want to capture the, a person ID or what have you. Where did it come from? The source and all that. But like I said, lineage, those are attributes of lineage, but that's the metadata of your lineage. Typically with lineage, we're dealing with the metadata. We're not dealing with the data content per se. We're dealing with what's happening to that information and so forth that is there. And we want to switch from being, as you know me, we want to switch from being reactive to being proactive. Lineage gives you a mechanism to work in the agile world, no matter if you want in Scrum or Kanban or whatever you have there, to be able to adapt to change and be ahead of your business coming to you with, this doesn't look right, where they can utilize self-service with lineage to be able to get at the information. And as a practitioner of technology and so forth as well, to be able to utilize it to make more informed decisions around what I'm bringing in and what the impact is as an architect as well. Now, the business benefits of data lineage, right? We talked about, we can already see how you can utilize lineage to help you. Now in lakehouse architecture, and so forth, it's even more important. When I was traditionally in the data warehouse environment, we were traditionally working with more structured data, and we were traditionally working with data we thought it had high variety and volume and so forth. But as I mentioned, because of modernization, because of cloud, because of the ability to scale on demand and so forth, we have to understand the nuances of that change. Keyword. Remember, I talked about buzzword bingo. One of the big things out there is what? DevOps and data ops, right? And being, and DevOps and data ops and continuous improvement and continuous development and all this other integration and all this other kind of stuff. Well, that's change. Change is happening more rapidly. And when you change something, it impacts something. So the benefits of these things is that customers that typically utilize Lineage as part of their governance strategy in the beginning on their report a significant decrease in the number of erroneous releases. Release management, not only is DevOps and data ops and so forth providing you more repeatability in the way that things get released and changed and so forth, but with Lineage and so forth, we have more of an understanding of those things and can adapt alerts and so forth when we see changes over time. Now, I already talked about impact analysis, so I'm not going to go into that again. But when done incorrectly, changes can result in bad things happening to the business, delays, your time to market in certain things, low quality deliverables, need for emergency fixes. I don't care if you have Jira or if you have DevOps or you're utilizing what's the ITSM, one of the ITSM tools out there, ServiceNow or what have you. Nobody wants 1,000 tickets of information that is coming through. It will be helpful if we can reduce that by introducing things into our methodology and so forth that allows us to track those things more effectively. But more importantly, can we tie information from one into the other through integration? And a lot of the tools out there in the Lineage space and so forth have REST services and so forth where you can integrate those things together. We also talk about one of the tools. Databricks has its own tool for that as well. But look at these benefits, right? 0 incidents with impact analysis. That would be nice. Faster and more efficient cloud migrations. Remember, I told you, my cloud migrations is the rage. That a lot of people are going through those right now. Sometimes there's still a little bit of distrust in security and some of those other things that way. How can we make those faster and more efficient? Regulatory compliance. Compliance. That's the big thing that's out there right now. And especially with tools in your lakehouses being able to support the volume, the variety, the performance that you need in compliance to be able to classification of the information that's in your S3 buckets or in your blob storage or in your textual information that's sitting out there. Now we need to know that if this has been identified as PII, PHI information that's out there, well, if it's being used in this report, if it's being used in this ETL, if it's going to this particular person, usage, wouldn't it be nice to know that I can meet the compliance auditability of that, but at the same time and so forth, I can utilize it to strengthen my security as relates to that, because you may not have known that certain things were being used by certain folks within the organization or by certain systems, or there are things that are out there that are running that shouldn't be running, or what have you. So regulatory compliance and so forth is a big one. And then the other is data consolidation and virtualization. Everybody's hearing things about data mesh and all this other kind of stuff, and how does that fit with the data lakehouse? And when we're consolidating things and the throwing virtualization and so forth with view, whether that be data virtualization of views and so forth like that, and the Lakehouse is a part of that infrastructure and architecture. How do we show where that information is and associate that over time? And I'm going to talk about a new one. Scientific SME. Oh, what the heck is that, Robert? Scientific, what does SME stand for? Subject matter expert. What the benefit of data lineage is, it reduces the need for you to have technical subject matter experts and business subject matter experts on call that may or may not have the ability to answer your question about where, what, and when, and how, because they have their own work and so forth that they need to be able to do. Wouldn't it be nice that we use an automated way through AI and machine learning and lineage and all these other things to be able to identify rules, identify where this information came from, and actually give you a way to search on that information from a lineage perspective? That's scientific SME. That leads to self-service for the users of the systems that have the ability to tap into your lineage application and your cataloging applications and so forth as well. Now, I'm almost done and so forth here, so bear with me. And if I'm running too close on time, for those that are monitoring my time, just let me know. But one of the things that I wanted to talk about is, we talked about lineage, we talked about lineage in the Lakehouse, and thank you, Bill, and so forth, about explaining the differences between the different types of environments that are in the Lakehouse and so forth, and being able to get back, being able to get at that information, what type of information that is, and why it's pertinent to the business now more so than ever. But what I wanted to talk about is, there's tools that out there that give you this. You can write your own. It's nothing. It's nothing more than a graph and so forth. But you got to harvest all those myriads of sources and all this other kind of stuff. But I think in 2020 or 2021, when the Databricks guys get on and so forth, they can talk to this more intelligibly and so forth. But with Databricks, there's a Unity catalog and so forth out there, and that's part of that Unity catalog. Catalog is nothing more. Somebody, like I said, when we get to governance a little bit later, they'll talk about the benefits of data governance. They'll talk about catalog. They'll talk about data literacy and some of those other things that are out there. But as you can see, as part of my catalog and so forth, not only do I have a description of the information that's there, not only do I know what the statistics about that information and so forth that's there, but it also shows you the lineage. That's how important it is, that these tools and so forth that are out there give you the ability to say, where did the information come from, how it was transposed, and so forth during that time. So I would like to end this up by saying I did a little bit of homework, Bill. In your presentation, you were showing the different applications that had fundamental transformations that were happening, right? You talked about gender and distance, and you had male, female in inches, and male, female in feet, and gender that was in centimeters, and the distance of CMS. It was going into your data warehouse or lakehouse, but now it was changed. It's all in feet. Well, if I only had access to this information over here, I wouldn't have known that it went through these transformations here. And if I'm being audited, or if I have compliance, think of it, this was some regulatory information that needed to be captured and so forth, I would have lost the fact that it used to be this. Well, with lineage, not only lineage gives you a textual way of getting at the information that's there, but typically it's being shown in a graphical way. Everybody used to say, coin the phrase, a picture's worth 1,000 words. If I can see a picture of it, it explains a whole lot more than me sending you an Excel spreadsheet of what this information and so forth is. So what I did here was just say, hey, you know what? This is what lineage is. Bill laid it right out for me. I had these three things. It got transposed and transformed into this. If I was asked, why was feet? Where did feet come from? What was the calculation of that? What systems did it come from? Can I look at this picture and say, yup, That makes sense. I know where it's at. Can you give me a report of this? If this thing over here changes, does that impact this? Yep, I can read it. Pictures worth 1,000 words. So, I thank you for going through that, because it just hones on the fact of why lineage is special and needed in your environment. I'm going to take one last system. I hope I'm doing well on time here. Yep.
You're fine on time.
Thank you. So I'm going to take another look at some information here. I actually have a video of something that Bill had in his book. I think it was on page 192 or 194. Bill can tell you what that is when they actually get back on. But he talks about, I think it was a broker's commission. And a broker's commission goes through many different things, right? It has to collect the payment, and then they have to do a bank deposit, and then it goes through another hop, and then it goes through another hop. When it's all said and done, something happened to his money. Now think if you were a broker. It doesn't matter what vertical you're in. Agents and insurance, brokers and consumer packaged goods, or vintners and wines and spirits and so forth. You want to know where your information, how did you calculate this information? It affects a couple different things. It affects people's current pocket, but it also affects what I talked about earlier, your corporate payment systems and so forth that are out there. And if those numbers aren't right, if those numbers aren't audible, there's fines, there's regulations, and all that's there. Let alone, forget about just from an auditable standpoint. When I give these numbers to my manager, and my manager is making informed decisions about about these things, and then it changes, it's not good for your manager, not good for you. And one of the things that a lineage allows you to be able to do is, even if there was a problem, it can highlight that problem and so forth for you. So a traditional data lineage application typically has certain features and so forth that are there. So in this case, the features are, does it show it in a graphical way? Does it allow you to trace where the information was and where the information went to? Does it allow you to get to what the calculations and so forth that were done along its way? And for extra credit, certain applications out there that have lineage and so forth have the ability to go back and tell you what the lineage was as of a particular point in time, because things change. What used to be how the information went from here to the ultimate target may have changed. So what does that look like? Well, what that ends up looking like when you actually take a look at it is, if we go and look at the use case that Bill had in his book, there's the bank deposit, there's the bank commission, there's your corporate book, here's your combined statement, here's your IRS report. Ultimately, these are all the things that made up information that went to your IRS report for that particular commission and so forth that was there, right? Well, there's one thing to say, hey, this is what the amount was, but where did it come out? How did I trace that lineage and so forth that was there? You see, when I highlight it, I actually saw where that information was coming from. It's the source. It went to this bank deposit and went to here. If it forked off and went somewhere else, it did a U-turn and went somewhere else and so forth like that, we see that picture and so forth in traditional lineage as relates to going into where? Into our lake house. Never forget the fact that I started this off with, what is lineage in the lake house? The lake house goes through all these turns and twists along the way to get information. Some information comes direct by file. Some information comes by text. Some information comes from streaming services that are there. Some information comes from REST services and so forth that are out there. No matter what the medium was, in order for that information to go from where it started to where it got to, if I can trace that information over time and tell you the rules that have been applied, and then export that information so it can be used by compliance, so it can be used by your management, so it can be used by your those that are utilizing your reports and so forth that are out there. There will be what? And I talked about this earlier. There will be more trust in the information that's there, and that gains more use of your systems. Now I'm going to continue. Not only am I showing you and so forth the lineage, but look at what we're showing you here. All those different rules, right? Look at that. If I know that my bank deposit going over to my bank commission system, the rule that was being applied against it was the current payment plus the bank commission. But if I continue down there, I will see, oh, but wait a second. When it went from the bank commission system into the corporate book system, we actually did some more calculation. We took the payment amount and multiplied it by a number to get the current balance. And oh, by the way, when it went somewhere else, there was more calculations and so forth done on that. Now, when I talk about these things, let's go back to the beginning. When I first talked about data modernization, when I first talked about metadata, when I first talked about the benefits, when I first talked about understanding where the information was and where did it go to. Now, one of the things that that's being shown here, how many of those, and now you can't raise your hand because I can't see you, but how many of those know about CDEs, right? Critical data elements. Oh, there goes another buzzword bingo, Robert. I got to trace those data elements and the changes that are being used inside of my lakehouse and so forth that are here. How have they been calculated? They're critical for a reason. How do they impact my dashboards and so forth that are out there? Well, if you have the metadata and information about that, I can tell you not only where it was and where it went to, what the calculation was, but ultimately as a business person, sometimes as a business person, I don't care what ETL tool you use, what data pipeline that it went through and so forth. Sometimes I just want to know what was the ultimate source? What was the ultimate target? How many transformation hops did it actually go through? And what were the rules and so forth applied against it? So your typical lineage, whether that be with Unity catalog or so forth, gives you ways of your Calibras of the world and Elations of the world. They're all have the some level of ability to be able to show you this level of lineage and lineage analysis. Some of the ETL tools and so forth out there have this ability, and they integrate and interface with Databricks and Delta Lake and so forth as well, because that's the need for information. Like I said, the compliance aspect of that. Most of the customers that we work with and so forth, and that Bill has described, there's always some level of compliance, especially when you're talking about the gold or the data, as the one gentleman had asked in the Q&A. Now, I've done a lot of talking. Got about some time and so forth that's left here, but I wanted to finish it up by saying thank you for giving us the time to talk about data lakehouse architecture and one core component in understanding what is in your lakehouse and your lakehouse architecture, what is lineage. And I implore you guys and so forth to spend some time in hearing some of the other presentations and so forth coming up, because it will relate what myself and Bill have talked about to some other core components and features and so forth that was there. So I just want to say thank you for your time. And if there's any questions and so forth, I turn it back over to the moderator. Thank you, Bill.
Thank you, Robert. That was a wonderful presentation. However, we have time for some questions. Now,
the answers.
And we hope we have some answers for you. The questions are being captured in chat sessions, and we will try to, at the end of the symposium, give a written document with the answers. However, now is your chance to ask me or Robert any question that you would like. Would you not share structured transaction data in the data lakehouse? And the answer is yes, of course you can do that there. That's a good place to store it. So you don't have to store it there, but I don't see any reason why. If it were my data lake house, that's what I would do. I'm looking at other questions now. Okay, returning to the example with gender and distance in the data warehouse. In the data lakehouse, should I do the same with gender and distance? Well, that's if you want usable analytical data, yes. Now, if you don't care about your data, and by the way, I don't know, pardon me, I don't know why you're storing it if you don't care about it, but if you don't care about your data, then no, you don't need to do any transformation. But if you want your data to be believable, useful, and available to people, I think the answer to that question is a yes. Now, I see a question about data products. I really don't want to discuss any products on this symposium. We are not a sales pitch for or against anybody. That's not who we are. And so I don't like to not discuss something, but when it comes to different products, I don't think that that is an appropriate discussion. Another good question. What policies are being established for privacy and protection of individuals as data has become the new gold oil? And do these companies profit from optimizing the data? Man, I'm telling you, if there ever was a hand grenade, that is a hand grenade. Because for example, when you get off into medical data, okay, let me tell you a little story. I don't know if you know the story about how HIPAA and medical data protection came about, but a number of years ago, there was a large insurance company that was collecting data on people that had HIV and AIDS. And somebody, a terrible person, I don't know who it was, but a terrible person took the list of known people with AIDS and HIV and made them public. Now, I'm going to tell you that was a horrible thing to do. I mean, that's a horrible thing to do. But what our politicians did was they took that one example of somebody doing something that was horrible, took that information, and then created the laws of HIPAA. Now, let me tell you something about HIPAA. HIPAA is great for the protection of individual information. But when it comes to doing medical research, HIPAA is the worst thing that happened to medical research. It complicates matters. It puts legal obstacles in front of people. It does some really bad things. So our politicians, as far as I'm concerned, and this is not a political statement at all. Neither conservative nor liberal. This is not politics, but our politicians overreacted to what happened at this one insurance company and crippled medical research. And I'll tell you, in this day and age of COVID, I don't think there's anybody. There may be somebody. I don't think there's anybody that doesn't understand the value of doing medical research. If we don't do medical research, COVID is bad enough as it is. It's going to get worse, and I don't think anybody wants that. And so, how do we combat that? Medical research is how we combat it. And the biggest enemy of medical research are the laws of HIPAA created by our politicians. And so, when it comes to privacy, privacy is a can of worms. Yes, there is this one school of thought that says we need to make information private. And I understand that school of thought, and that's a valid school of thought. But there's this other school of thought that says when we go overboard and make the information so difficult to get to, that that has an evil consequence as well. So anyway, that's just and it goes well beyond the world of medicine and healthcare. It goes into lots and lots of other worlds. So that's a little bit about that privacy and the data lakehouse. Okay, single version of the truth in the data lakehouse. My best answer to you is that yes, you need to have the single version of the truth in the data lakehouse. Yes, I agree with that. But the data lakehouse, let me tell you one of the constraining factors in the data lakehouse. When it comes to machine generated, okay, I want to contrast machine generated data with structured data. In structured data, when we need to transform data, it's reasonably easy to do. I mean, it can be done. That I know for a fact. So taking our structured data, transforming it, and creating a transformed notion of the data, we can do that. We can't do the same thing with machine-generated data in our data lakehouse. Why? Because there's too much of it. There's simply volumes of data that we find in the of machine-generated data in the data lakehouse that we can't even consider the same kinds of transformation that we find in the structured environment. So that's a little bit about the constraints that we find in the data lakehouse. Okay, let me scroll down and find some more questions. Again, I'm not going to talk about products about anybody, including Databricks or my own product. We're not here to talk about products. Okay, now this is an interesting question. The data lakehouse paradigm, is that a dream or reality? Right now, it's something that's becoming a reality. I mean, once upon a time, data warehouse was just a concept. Nobody had a data warehouse. And then we look up today and everybody's got a data warehouse. Databricks is in the same state. Databricks, pardon me, I don't mean Databricks. Data lakehouse is in the same state. That today we are just formulating our ideas about what a data lakehouse is. And yes, there are some examples, and I think we're going to hear from Databricks to give us some of those examples later on this week. Yes, there are some people that are doing a data lakehouse, but it's still in its thought leadership formative stage. If you wake up 5 years from now and 10 years from now, when we have data warehouses, we're going to have them all over the place. You're going to find a data warehouse everywhere you look. So I hope that answers that particular question. Next question, do you think that the next leap in data management could be the sort of autonomous database? The problem with autonomous databases is they all tend to be very little. I liken, when you mentioned the word autonomy, what I think of immediately with autonomy is the Excel spreadsheet. Now, Excel spreadsheets are in the corporation everywhere. You find them everywhere. And so do they exist? Of course they exist. Are they useful? Of course they're useful. Are they reliable? Absolutely not. Why? I can take an Excel spreadsheet and I can say that Bill Inman has a salary of $1 million a month. And I can put that in an Excel spreadsheet and it's on a computer, it's whatever. Is that reality? No. Bill Inman does not make $1 million a month by any stretch of the imagination. But can I put that into a form that is not reliable? And the answer, and that's the problem with autonomous databases. With an autonomous database, you don't have the ability to verify the accuracy and validity. If Robert was talking about the data lineage with a spreadsheet, the lineage, I don't know, maybe you do have lineage, but I don't think you. I think lineage is a very sketchy issue when it comes to autonomous databases. So I'm not put it like this. Yes, of course you can have autonomous databases, but if you care about believability, if you care about accuracy of the data, I don't think autonomous databases have a bright future. Okay, here's an interesting question. How do we move forward when so many companies with data lakes are not interested in data modeling? That, as far as I'm concerned, is a reflection of the immaturity of the industry. And by the way, when I use immaturity of the data lakehouse, that's not a pejorative term. That's simply, as we discussed in the very beginning, part of an evolution. We are seeing an evolution here, and evolutions take time, and evolutions are not perfect. The way people evolve is to make a mistake, learn from their mistakes, and then go from there. And for those companies that simply threw data into a data lake, they're discovering something. They're discovering that a year later, their data lake is a swamp, and you never intended for the data lake to be a swamp, but that's what happened. And so that's why the evolution is from a data lake to a data lakehouse. The data lakehouse adds all of the elements that you need to make the data usable, something the data lake doesn't have. And when Robert was talking, he's talked about the lineage of data. Now, there's other aspects to it. I mean, the lineage is not the only thing that is important, but certainly lineage is one of the aspects. So, yeah, you can create data lakes, and you can just throw your data into the data lake and see what happens. And a year from now, you're going to find not much good has happened. In order to use the data lake, you've got to have the analytical infrastructure that we're going to talk about. Now, today we talked about data lineage. Tomorrow we're going to talk about some things about the textual environment. So we have different aspects that we're going to cover. This is like today, Robert played the violin for us. Tomorrow, we're going to have somebody play the flute for us. The day after that, we're going to have somebody play the piano or drums for us. So, so anyway, the fact that corporations, I guess I have to blame. I'm not going to mention any vendor's name, but I have to blame certain vendors that say, okay, they went into the data lake without understanding architecture. And that is a dangerous and bad thing to do. And the companies that end up with a data lake without the analytical infrastructure have a problem. I didn't create the problem. I don't even like the problem, but that's evolution. The data lakes will either evolve or die. Another question. I'm looking at the clock, and we don't want. Now we're going to try to answer all of these questions in a written form at the end of the seminar. So I'm going to take one or two more questions, but this next one is really interesting. What is the ideal way of modeling the data in a data lakehouse? Now that, sir, is a really, really interesting question, because the only commonality that we can find are these very universal connectors, which we talked about. But the data modeling techniques that we learned in the structured world don't work well in the machine-generated world, and vice versa. So modeling is something that's going to evolve. Yes, we can use the universal connectors that we talked about, but I'm going to be the first person to admit that that's not the final answer. I mean, I'm going to tell you, I don't know what the final answer is. It's the next direction down the path, but I don't know what lies a quarter mile down the path. Thank you for your attendance, and I hope you've enjoyed this presentation.